We started the new bullet project several years ago, and it turned out to be a whole lot more challenging than we ever thought it would be. During the course of this thing, we ran into several things where we thought we had it and then we didn't.
We had a bullet that was done. It was ready to go.
We were getting ready to launch it. We were getting material ready for marketing.
And then we started doing the last of our Doppler radar testing to look at, okay, what's the BC of this thing 800, 1,000 yards downrange?
What you can learn from Doppler is incredible. It gives you a complete flight path and all the characteristics that goes along with a projectile in flight.
We were able to dig into the drag curves that the radar gives you and find out very, very detailed that, hey, the drag of this projectile is changing rapidly at high velocities. It shouldn't be doing that.
We discovered that there was a portion of the bullet that was changing shape in flight. That's what was causing the issue with the dropping BCs.
We pretty much came to rather quickly that the tips are melting. They have to be melting.
So with the current polymers that we were using in tips, the tips were deforming and melting in flight, and that increases the me-plat diameter, the point of the bullet. When you do that, the ballistic coefficient drops, the aerodynamic drag increases.
And that was the light bulb that clicked on. We can see it now. We know aerodynamics heating there. Something's changing, gotta be the tip. How do we solve it?
This led us then into the study of where's the material and what kind of material can we get that will allow us to fix this problem.
We dove into the material properties of plastics. What's their melt temp? What are they at room temperature? What type of heat transfer characteristics do they have? And we arrived at a material that can handle elevated temperatures for longer periods of time.
It's a material with 2.5 to 3 times the melting point temperature of the currently used materials. And it's a molded plastic part. These you can get exactly the same point on the bullet every single time, every single bullet, and every single lot of bullets that you make.
When we made our initial discoveries and we started looking at what the implications of this would be on the industry, it makes you sit back and kind of smile because it's going to be huge.
This solved a problem that none of us ever really fully realized existed before.
We definitely surpassed our original goals with this project. The discoveries that we made and the information that we learned, it's allowed us to build the best bullets that we've ever built.
The ELD X bullets really are a new class of hunting bullet. There isn't anything else out there like them.
Our engineering staff was tasked with putting together really an all-range hunting bullet. Not only did the bullet have to work terminally, expand, provide penetration at closer ranges as well as extended ranges, but for it to perform well at extended range, it had to be extremely accurate and have a high BC. So essentially, they were tasked with making the ultimate bullet.
We wanted to come up with a hunting bullet that you could shoot a match with.
This bullet is difficult to manufacture. We're blending a couple different technologies that we use. We're taking our amp jacket technology used in our match bullets, and we're blending that with the interlock technology of our hunting bullets, and blending that with the tip-initiated expansion. And all of those had to come together and work in harmony.
Heat shield tip is a total game changer. It gives you a completely 100% consistent tip shape from bullet to bullet, lot to lot. You can't get that with a hollow point. You can't get it any other way.
One of the things that we're trying to establish by using a tip like that is a ballistic constant. And by using the material that we're using, we know that it's never going to vary regardless of what our customer is doing.
Another thing the tip does on the aerodynamic side is it's the perfect me-plat. You can mold those things perfectly every single time.
Because the ballistic coefficients are higher, these things shoot flatter, they have less wind drift, and we're getting better groups and elevation because everything is consistent now. They are truly match accurate. These bullets shoot the half MOA or better. They're right there with any match standard that exists for a match bullet, and they're a hunting bullet.
One of our objectives is to make sure that we are building an ethical product for our consumer. And we know for a fact from doing all the studies that we've done that the only way that you can get reliable expansion is with some form of a tip.
The heat shield tip is what initiates the expansion of the ELD X. The relationship between that tip and the rest of the bullet, the cavities that we use around the tip, and the way the tip fits into the bullet all control how it performs terminally. The conventional range terminal performance of this bullet is slightly unorthodox. The bullet is designed to continuously expand instead of expand to a certain diameter and then stop.
Because it's doing that, you get large temporary wound cavities that are longer than conventional hunting bullets. And what that means is you get massive hemorrhaging and internal damage that makes this projectile extremely lethal.
At longer ranges, say 800 yards, you're going to get 1.5 times expansion, and you're going to get 85–90% retained weight, and you're going to get 2 feet of penetration with, again, very, very large and very, very deep wound cavities.
So the end state of these bullets is you have a bullet with a high and constant BC. You have a mechanism for expansion in the tip. That's what ensures the terminal performance. It works at close range, conventional range, and beyond conventional ranges. No other bullet out there can do that. At the same time, you have a reduction in vertical stringing. You have an increase in accuracy, essentially, because the tips aren't deforming differently.
This thing is phenomenal, and the technology associated with it, not only in the production of the bullet, but the revelations discovered in the testing process, the implications are going to be huge for the industry.
These bullets do exactly what we say they do. The ballistic coefficients are exact. The flight paths are exact. The terminal performance is perfect.
We far and away exceeded the goals, for the bullet and what we thought we'd learn with the project.
When I think back to when we initially started it and where we thought we would go with it, this is a whole different animal. This thing is leaps ahead of what we thought we could have done originally.
We are at the cutting edge of research and development and the introduction of new and innovative products to the market. We actually have proof that this is going to improve what that hunting bullet does for our customer.
There is a separate development here that's actually bigger than having an expanding bullet that will work at all ranges. Now we've come up with a way to just make bullets better.